Yeah, great. So it looks like we have a few more joined us, so 9 students. So feel free along the way if you guys would like to unmute yourselves or put a question in the chat, feel free to do it. We'll probably answer those in real time if you guys have them. But roughly what I want to start with is you're obviously all interested in electrical engineering at ASU, and it's a great choice. There's a lot of prospects in it. I like to, as far as the student services role that I'm in, I'm very pleased and excited to work in a group that's kind of tight and we know our students very well. Among the Fulton Schools of Engineering, we kind of have a smaller freshman class, which is great for you. It's not tiny though. We have about 200 every year that start with us. But the point I like to drive home is we know you guys all intimately very well. You get assigned an academic advisor who kind of assists you with the day-to-day needs of students. And you'll also work with a faculty during your first year very closely. Dr. Ali, for example, is one of our ASU 101 faculty members, and he teaches you directly in a 19-person class. So I know sometimes the thought of starting school can be a little intimidating because you're going to join this large, massive environment, and you hear the numbers of ASU and even the numbers of us being quite big. But I like to remind everybody that you'll know someone like me, you'll know someone like Dr. Ali very early in the process. Another thing I want to do very quickly is I want to give you a, you guys are all able to look up our information about us on our on our school website. It includes a lot about our faculty, about our research areas, that sort of thing. But what I want to point at now is what it is you'll be doing in the beginning. I won't get into the details in it, but the goal that you'll have when you start here is to develop your foundation in calculus and physics and take your general studies courses, and then kind of work towards, through your 4-year journey with us as an electrical engineer, into determining which kind of area of focus that you'll develop the biggest interest in and take a couple extra courses in. We call these the pathway areas. So anybody in the room now, are you interested in this because you're curious about power systems? That's often very popular. Feel free to shout out if you are. Maybe you're interested in circuits. We have a lot of students who tell us stories about how they got interested in this just because they like taking stuff apart and playing around with circuits. Another one of our areas is communications, signal processing. I'm going to speak a little bit more about that later. Solid state, and then the electromagnetics area is another one too. So as you work through your electrical engineering journey, remember, as a first-year student, you don't need to know all this stuff just yet, but you do need to work towards just to know what to do between now and the start of school. You know, giving your memory a jog of calculus or firming that up, or and physics knowledge is important up front. Even if you're not testing into calculus just yet, we support you on that too. So I want to kind of, we have a way to support you throughout this whole, no matter where you start, we have options for you. So we'll come back to that one in a little bit, and then actually I do want to show you this real quickly. If you get curious about more information, and if you'd like to know more about these areas, we are providing these on our website. You can click on the Pathway Seminar links, and we're recording these as we go, and we have them posted. So these are Zoom recordings, and they're not they're just our faculty talking to kind of sophomore, junior, senior level students, but we put them on the website. So if you're curious now, if you're generally interested in electrical engineering and you'd like to know more about, well, what is controls? What does that mean? What is power systems? Who are the faculty in the area? What does it mean to be a signal processing person? We have these on there. In the circuits areas, we have one there too. So again, these are presentations that may or may not be the most engaging and exciting, but they're going to give you a good feel for what it is. I highly encourage that as you start in here. The other thing I want to mention throughout your journey is This will all, your program will culminate, I'm going to stop that right now, sorry about that. It will culminate in what's called your capstone project. So all engineering students, you may have heard of this already. You'll start with your curriculum, you'll go through it, you'll develop your interest area, and you'll leave with sort of a professional product or presentation that will help you in your career growth and in your professional growth. And we'll give you some examples of that before we're done here. And I'll do that in just a moment. What I mentioned briefly on that website, and I encourage you to look more, but we're a very active school in terms of research. We're among in the Fulton schools, we have some of the highest research expenditures in the university, really. And our faculty who are in those research groups, folks like Dr. Ali and others, are also our main faculty, and you have direct access to them. David, did you want to touch base on that maybe now and talk about your experience as a center director?
Certainly. So I guess, first of all, can I say a few words about what electrical engineers do?
Please do. Good idea.
So I know when I was your age, I didn't know what electrical engineers did. And I actually started out as a pre-med student. And in order to pass the time I did engineering, I was actually in chemical engineering. And then I went to the library and got a book on circuits, and I couldn't figure them out, and that made me mad. So then I switched to electrical engineering so that I could solve some of these problems. So life has a circuitous route. And I didn't, so when I was your age, I didn't really know what electrical engineers did. But if you're trying to get your mind around what electrical engineers do, just think of your cell phone. Your cell phone has inside of it just about everything that we do. So the cell phone has, well, it has circuits inside of it. There's lots of integrated circuits, chips, both analog and digital. Well, electrical engineers designed those. Well, inside of it, there's an antenna because you have to broadcast to the tower. Well, electrical engineers design antennas. That would be electromagnetics. Inside, there's a lot of signal processing because you want to compress a person's voice down to just the minimum number of bits that you have to transmit so that it can be decompressed and understood on the other end. This minimizes power consumption so that it lasts longer, your battery lasts longer, maximizes bandwidth so more people can talk over the same frequencies at the same time. So there's a lot of mathematics and coding in the signal processing inside a cell phone. Electrical engineers do that. All of the circuits depend upon transistors. CMOS, MOSFETs, bipolar transistors, power amplifiers inside the cell phone. And so that's what's the physics of how these transistors actually function, and how do we make them better, and how do we build them? Well, electrical engineers do that as well. Electrical engineers, power. Well, the cell phone runs on a battery. The electrical engineers do batteries, although they work closely with chemists on that. But in particular, that battery had to be charged up somewhere. And so there had to be a power plant, a solar plant, a wind farm, a gas-fired plant, a nuclear power plant that generated electricity and over power lines got to your house so you could charge up your phone. Well, electrical engineers do that too. So I think the cell phone is a good example of a cross-section of what electrical engineers do. They produce those kinds of products. Maybe the one thing I've left out that I can't find in the cell phone is control theory. I'm sure it's there. I'm just not quite sure where. But control theory probably relates more to robotics. And we have a new program starting at the master's level in robotics. And so that involves mechanical engineers as well, but the control with algorithms and circuitry is done by electrical engineers. All right, so that's the brief description that I wish someone had given me when I was your age about what electrical engineers did. And so now we can go on.
They had cell phones back then?
No, we had payphones. We put in dimes to make phone calls. And there was no internet either. And you may wonder how we ever got anywhere. We used paper maps, and we got lost a lot, to be quite honest. It was a different world. Yeah. The wild, wild west, yes.
So the other, so thank you for that. That was an important segue I left out. I did want to speak briefly about some of the research areas of our faculty, and I'll lead Dr. Ali back into that. Recently, in the news, obviously, a lot of people are studying how to manage COVID-19 all those other things. And in the news, you may have seen that some electrical engineering faculty and others at ASU have been involved in research funded by the National Science Foundation to use your cell phones to kind of alert you to a risk area for contracting the virus. One of those, there's a couple folks who received in our school received grants from the NSF to study this. One is Dr. Andreas Spanias, and he was heavily involved in one of those projects, and he's a signals processing faculty member. So they're studying signals, and I'm not the engineer, so I won't go into depth on that, but he's studying that from how to use the signals to help people predict. And I believe Dr. Lalitha Sankar in our school is also involved in that. Do I have those two names right, Dr. Lalitha?
Correct.
Yeah.
So we have 75 faculty, almost all of which have active, vigorous research programs that bring in a total of $35 million a year in research funding. And this research funding is from companies, mostly from the federal government. The way this works is faculty write proposals to solve problems that have been proposed by the National Science Foundation or the various defense agencies. And it's a nationally competitive process, very competitive actually. And the winners of those proposals get research funding that's then used to run research programs, hire students like you in a few years to work on their master's or their doctorate. And for the doctorate, typically you would get your tuition paid and you would also get a stipend to live on. And that's how research is done. But as undergraduates, you have opportunities to get involved in that research as well. We have a variety of programs. One of the best is the Fulton Undergraduate Research Initiative, FURY. It's not furry, it's FURY. And so that you write a proposal as an undergrad in collaboration with professors in electrical engineering to get involved in their research as undergrads. I had an undergrad who joined me from the time he was a freshman and published papers in IEEE journal articles as first author, and is now working on his doctorate at my alma mater, Stanford. And so you can get involved at an early age in all kinds of research. I have some videos to show here later on of some of the research I was involved in, but I'll turn it back to Bob.
Yeah, David, this probably would be a good time for that. I didn't want to go through all the centers, but I did want to say the signals area is one of the big ones that we recently had some articles in. But we don't need to go through them all. There's many, but this would be a good time for Dr. Ali to share his info.
So we have substantial research, many centers. We have a center for photovoltaics, an engineering research center, a very prestigious one funded by the National Science Foundation. Many faculty and students are involved, and they're developing better solar cells. We have research centers in all sorts of optical devices, signal processing, power, antennas, and so on. I mean, the list is really very long because essentially all of our 75 faculty have significant research programs of their own. So I can show you some videos. So in 2004, I was a co-author with a number of other faculty on a big proposal to, the Army had put out a call that they wanted to put together a small volume manufacturing line to build displays. And this was a manufacturing line. Now, it's small scale, it's prototype. And the idea was that they wanted displays on plastic. They wanted soldiers to be able to wear displays so that they could get real-time information in the field without falling or breaking the display, right? So it'd be plastic and wearable, you could fall on it and it would still work. And they would want two types, one that's color and then one that's just like an Amazon Kindle, it's black and white that doesn't emit any light. So this was a nationwide competition. This was huge, huge money. It was about a $100 million contract over 10 years. And we competed with this. You know, we were the lightweight. We were wound up being one of the final four. And the other teams that we were competing with one was from Cornell, and one was from Princeton, and one was from Texas. And then there was us. And it was particularly sweet because the guy leading the one from Princeton was my colleague at Stanford. And so, you know, they thought for sure they had this in the bag, and we actually won. So this became the Army's Flexible Display Center. And we set up shop in a building, an ASU Research Park that used to be Motorola's worldwide headquarters for their display manufacturing. Motorola had gotten out of that business, and the building, the huge building, was sitting empty with something like 40,000 square feet of clean room space and countless laboratory rooms and offices and so on. It was really embarrassingly nice, actually. And this was sitting empty, and so we bought this building contingent on winning this proposal, and then we did. And it was a collaborative agreement with the Army, so Army physicists and were there almost all the time. And we built, set up a manufacturing line to do this. Now, we know that faculty don't really know how to do manufacturing, so we had the wisdom of going out and hiring 30 or 40 or so engineers and technicians from industry that actually knew how to do manufacturing. And we then held some leadership positions, and I was one of the 2 directors of research there for experimental flexible circuits. And so I have, this ran from 2004 to about 2015 or 16. It was successful. We ran a couple extra years, and it has shut down now. But we met all of our deliverables, and I can show you some of that work. If I can share the screen here. Let's see if I can get to this point. Let's try this one first. So here is just it disappeared. Oh, there it is. Can you see this?
There it is.
Okay, so this is a photo of a flexible piece of plastic that is a display. So it's actively driven display. You can put movies on this, and it's about a 1/3 of a meter by a 1/4 of a meter in size. So this is a big sheet of plastic. And so it's like a flexible television, if you will. And now there's a few lineouts in here. And so you may say, well, this is not really quite ready for commercial sale. And that's true. And basically what we were tasked with doing was flexible displays had been invented by Princeton under a military contract, but that was a science project, right? Build me one. Okay, so Princeton did that, and that was very impressive. But now the Army wants to place an order, right, for flexible displays, and all the displays in the world are made by large Asian display manufacturers. Well, they're not going to touch a science project. And so our task was to take Princeton's technology, which had been done really with some academic tricks and shortcuts, and turn it into something manufacturable. And so there's a lot of really hard manufacturing problems to deal with that we had to confront. And the goal was to get it up, scale it up from just being a display that's a few inches on a side to something that's like 1/3 of a meter to a 1/4 of a meter, and get it to the point where there's just a few lineouts. Because if you can get it to this point, then one of our members, LG, a Lucky Gold Star, LG Displays in Korea, would take it over and commercially make this, and the Army can place an order. So that was the task. Probably the most difficult challenge we had was you're going to use flat semiconductor equipment or display equipment to do this that's normally done on glass or silicon. Those are rigid substrates. And so you want to glue the plastic down and process it at low temperature, not at high temperature, because the plastic will melt at high temperature through this equipment that's commercially available. And so probably most of our patents, we have many patents that we developed and are licensing. And probably the biggest problem was, how do you glue this plastic down and then get it off at the end without damaging the display? It's got to stick. It can't slide. There can't be any defects or bubbles between the glue and the substrate. And after you're done, somehow you have to get it off without damaging the display material or the plastic. And so that mundane manufacturing problem is actually where most of our intellectual property was developed. There were other patents as well, and I'm on several of them that were related to other things. But that was a lot of very serious manufacturing problems. There's a lot of fun there at the center. I got to meet several 4-star generals, including the first female 4-star general in the Army, General Ann Dunwoody. And it was quite amazing to see this petite woman come in with stars on her shoulders, and Colonel slamming the doors open for her. So that was quite interesting. So the other type of display that we made is essentially this one. This is a small electrophoretic display. It's an Amazon Kindle on plastic, if you will.
I don't think the next one moved over, David. I think we're still on the...
Oh, still on the previous one? Thank you. So let me stop sharing and share a different one. Thank you for the heads up. Okay, can you see this now?
Yep.
Should say Flexible Display Center on a black and white display.
Yes.
Okay, so this is a small electrophoretic display. It's an Amazon Kindle on plastic. And this is for a soldier to wear in the field. The previous one that's color would be inside a command tent out in the middle of nowhere. and that you would hang on the wall, or maybe put inside a tank, you know, because there's no room in a tank. I tried to get a ride-in one, but I didn't get one. But they tell me there's no room in a tank, and so this would be like wallpaper that would go up on the inside of the tank of the previous one that was color as a monitor. And so this one, the black and white one, is something you would wear on your wrist. And so you could look down and get real-time information in the field so that you don't get surprised. Soldiers, we don't want our soldiers surprised. Now, this has to be extremely rugged. And so we have about 26 corporate partners, including General Dynamics and Raytheon, and they took our displays and put it through their standard military tests for their displays. And so this is a movie of those tests. So let me play this. So there's our flexible electrophoretic display. We can run movies on this. And this is our ruggedness test to make sure it passes the Army ruggedness. All right, so you can bend it. It's stable like a Kindle is. So this is the shake test, right? So this is bouncing along in your Humvee going down a road in Iraq, right? So it's still got to work. Right. This is a live display, so we'll actually be showing some images on it. See, the image is changing there. So this is actually running with drive electronics. And there's the display changing, putting a map on it. All right, so this is the ball drop impact test, right? So something has to be able to hit the surface and it not break. There we go. Display still works. Right. Yep. And then the next test, let's see, I think we'll show the next test here in just a moment. This is the boot test. So this is a Marine jump or an Army soldier jumping into a Humvee and kicking the display with his boot. So this is a lever arm is going to be pulled up and then swing into this display while it's active. Don't do this to your cell phone. Okay, it discolors the electrophoretic display, but on the next frame it clears it and up comes a manual, so I guess you could fix your Humvee right there on the spot. So that's just one example of the many kinds of research that ASU is involved in, and be happy to take any questions you might have. We have research in bioelectronics, implantable electronics, countless areas of research, photovoltaics. We have a nuclear energy program. There's signal processing. There's a lot of, we're starting a graduate degree in data science. There's a lot of faculty working in machine learning. What am I forgetting, Bob?
I did want to share Dr. Jennifer Blaine-Christian with us, as I was speaking with her in a student reel recently about her interest in wearables. So I know a lot of students are curious about their smartwatches. I use a Garmin watch, and they're interested in using them to even remote diagnose. That's kind of an interesting technology. So she's also interested in this concept of universal design, which is the idea that we can do engineering work that serves everybody, from abled to special needs, all of the above. So we have a lot of really cool things going on, and all of our faculty have fantastic stories, like Dr. Ali shared. But we generally get some questions here, and feel free to take your mics off. And we've been talking for a while, whether it's about curriculum. No question is too basic. So if you're curious about, if you don't know what one of the areas we mentioned is, we can give you a brief definition of it. This will be just pretend this is the first day of college and the professor is pressuring you to ask a question.
So we all have office hours. In electrical engineering, we all have office hours. All the professors, all 75 of us do. They are posted every semester on the EE website. And during those office hours, you have a right to go by any of the 75 faculty members' office and ask them questions about anything, whether or not you're in their class. And so sometimes students come by my office and just tell me about EE careers. Tell me about, I want to go to medical school as an EE, or I want to go to law school and do patent law. What's your thoughts about working with NXP? I'm happy to share my opinions. They're just one opinion, so you should probably get a few from different faculty. But we are there to advise you on just about anything you'd like to talk about.
It looks like Nathan has a question here. It's in the Q&A. I'll read it to you, Dr. Ali. I think this is best for you. He's asking, do you partner with other departments for projects, for example, material sciences to develop superconductors?
So yes, we are collaborative with other departments. I've been on many proposals with other departments. The Flexible Display Center was a proposal with chemical engineering and material science, and electrical engineering was a smaller part of that. I was probably the electrical engineering representative there on that proposal. So frequently we make proposals across departments. Now with regard to superconductors, a colleague of mine from Stanford who's a faculty at ASU, Nate Newman, actually has a large program in superconductors, and he's out of the SEMTI school, the School of Energy, Materials, Transport, and Matter. Okay, it includes material sciences in there. We have these unusual names that at ASU for these large schools. Ours is fairly understandable, electrical engineering. Some of them are rather creative. So he has a large program in superconductors, and he's in material science. And so yes, there's opportunities there as well. So yeah, cross-disciplinary projects are very common. I had a project I advised which was a senior research project, a senior capstone project that was entirely computer science students. There weren't any electrical engineers in them. There was 6 computer science students, and I challenged them to try the IARPA challenge. IARPA is the Intelligence Advanced Research Project Agency, and they had a challenge out about who could use open source intelligence like Twitter feeds and analyze them and predict a civil unrest in Egypt. Right, so this was quite an unusual project, and so I put it out there, and these computer scientists showed up and said, yeah, we want to give that a try. And so yeah, I advised half a dozen computer science students. So yes, we're very cross-disciplinary. Faculty know how to hunt for their lunch, so we go wherever the money is on research.
Thank you. Yeah, and David, also, I should mention at the graduate, as you start as an undergraduate, you're developing your foundation and you can get your feet wet with some of these research projects. But just know that it's not challenging and it's not as tough as it seems to transition into a master's program. And we even have accelerated versions of that where you can complete it, a master's and a bachelor's degree in 5 years. It's called a 4+1 program. And we have interdisciplinary electrical engineering options like the Robotics and Autonomous Systems master's degree is an example of that. The computer engineering program has electrical engineering focus as an example of that. And the data sciences program, which is kind of in line with maybe what Dr. Ali was just talking about, is in there too. And I don't want to forget, Dr. Ali, Karen Cully is asking us a question, asking us what solid state devices are.
So solid state devices are transistors primarily. And so when we build these circuits, the circuits that you find inside your cell phone, they process bits of ones and zeros. And so we need very tiny transistors that turn on or off like switches. And so those solid state devices, the primary solid state devices is a MOSFET. It's called a metal oxide semiconductor field effect transistor. Essentially, you put a voltage on a piece of metal and it controls the conductivity between 2 regions of a semiconductor. And Intel has gotten very good at this, as has Samsung and other companies, and they can now put billions of those transistors on a single piece of silicon that's a centimeter by a centimeter, or an inch by an inch. So that's how far the industry has come since the planar integrated circuit was invented in 1959. So a solid state device is a device that is like a transistor that's built in a material, a semiconductor, typically silicon. But it doesn't have to be just that MOSFET transistor. There are other solid state devices. A solar cell is a solid state device. It's usually built in silicon, but can be built in other things. You can have very high frequency amplifiers built in other exotic materials like gallium arsenide, but it's a solid device, it's a solid material, so it's a solid state device. So solid state means that the transistor is built in something solid, if you will, usually some crystalline semiconductor.
Thank you. Thanks Nathan and Karen for those good questions. Those are how learning happens, especially in a new area like this, science and engineering, and questions are the starting point to make any real progress. Any others out there? Right, here we go. Oh, I think this was a student who was asking about graduate programs. This specific webinar is not geared towards graduate programs. I think Sharon, he's
Yeah.
replying to something you said.
I'll connect them with graduate recruitment, and because I believe they have sessions this week as well. So.
Oh, I mean, they're doing them very frequently. So
Yeah.
please join one of those. They'll get more specific questions there. Thank you.
So the other thing I really like about Arizona State University is that it is so large, because there are all kinds of activities that you can get involved in. With over 100,000 students, I don't care what your interest is. It could be CubeSats, it could be Hindi movies on Friday night, it can be space exploration. Whatever your interest is, we've got it somewhere here on campus. There's art programs, Broadway plays come to Gamage every several times a year. So whatever your interests are, ASU has it, and so it's a wonderful environment to explore hobbies while you're learning a very valuable skill to make a living in electrical engineering.
Yeah, I love it here. I've just personally, my job is purely administrative. I'm not an academic, but I've been here about 15 years. I've worked at other schools besides ASU, and I absolutely love ASU for the reasons Dr. Ali mentioned. I went to quite a small school, and the difference between a large and a small is pure opportunities. And what I think our school does much better than many even others at ASU is, you know, maybe it's the nature of what we do, maybe it's this the smaller kind of interest areas we have, but we know our students very well. So even if you get in a situation where you're, hopefully this wouldn't happen, but you start as an electrical engineer and you decide it's not for you, it's really not that big of a challenge. We can get you where you want to be, and we'll work with you. And when you're at a large university like this, we're going to have what you want. So it's a good situation. Does anybody here want to share, or do we have any non-Arizona folks in the group today, or are you guys all Arizona folks?
Anyone tired of shoveling their driveway out there?
I'm from Chicago, so I can speak to that. Well, I grew up in the western suburbs of Chicago, but lived in the city for a few years after college.
So we have a wonderful space and Earth Science and Exploration program. It's called CC. It's not electrical engineering. It's a separate school. It's a separate department, but it's very prominent. And we work closely with them. Some of our faculty are, I'm one of them, are closely tied with them. They are a bunch of astrophysicists that study space and planets and the Earth as well. And they have a wonderful seminar there every Wednesday at, I think it is 3:30 in the afternoon, 3:30 to 4:30, held in a large auditorium, and they have prominent astrophysicists and scientists from around the country coming and giving these beautiful seminars about the Hubble telescope or the new James Webb telescope and so on. It's exciting and it's understandable, so it's meant for a broad audience. And so I encourage you as students to explore these kinds of things at ASU and show up, take some time and go to a seminar or two every week. Once you leave the university, you'll miss being here.
Yeah, some of us chose not to leave. That was my excuse. That's why I'm still here. I love it. So we'll help you make the best of it over the next 4 years.
Well, at one point, I was interviewing for a job at Motorola, and I've been a faculty for a number of years. And I asked them, "So where is your rec center so people can exercise?" He said, "You've been a faculty for way too long."
That's right.
We have a wonderful rec center here at the university.
Yeah, and it actually is open. So there's a lot of questions about how it's working, and it is open where it's open on a reservation basis. So you can go work out. You just need to plan ahead so they can do their social distancing plans for this. So we're still doing what we do. Well, if we don't have other questions, I don't want to keep everyone here too long, but I hope that you feel free to reach out to us, I believe, through Sharon if you have questions. Is that how that works? And
yes, you will be. Yeah. sorry, you'll be receiving a follow-up email after this session, so you can contact us that way. And know that we also have Fulton ambassadors who are current Fulton majors that who can speak with you one-on-one virtually if you would like to get more of the student perspective. We'll match you up with someone who has the same interests as you, and you can ask them about co-curricular activities, the research that they've done, what classes you should really prepare for, or faculty to avoid. I'm just kidding. But yeah, our Fulton ambassadors they're here to help prospective students make informed choices and also connect you with your resources. So thank you to Dr. Ali and to Bob today for introducing us more to electrical engineering.
Thank you, Sharon, and thank
Mhm.
you, Bob. And I look forward to meeting all of you. I have office hours. Please stop by and see me.
All right, well, thank you all. Thanks for taking the time today. Thank you, Dr. Ali. Thank you, Sharon. And Amit was asking if he could have the link to,
Yeah, I replied to him. So.
Oh, good. Yeah, so
Yep.
we'll get you connected. Amit, I'm going to put my email in here if you need it later. If you don't get what you want, just go ahead and email, and all of you can use this too. So feel free to email me at that address I put in there if you have any question that you had tonight you didn't want to ask out loud, or if you didn't get your answer about the graduate recruitment events. We'll get you there. So thanks everybody. I'll go ahead and click off. Does that work for you, Sharon?
Yep, that works.
Thanks
Thank you.
again, everyone. Have a great night.
Good night.
Bye-bye.
Good night.
Good night.
Take care all.